So invariably, one of the more difficult questions for students to sort of ponder is how to convert between solution concentration units. Here's a typical problem. This is a 20% sucrose solution. It gives the molar mass of sucrose. It has a density of 1.084 grams per milliliter. Calculate the molarity and molality for the sucrose solution. So when you're doing problems like this, right, the hard part is like you only have a percentage and you only have a density and a molar mass. So how do you even approach the problem? And I usually tell students to think of it in terms of the units. So let's take molality, for example. Molality is moles. I'll write it underneath. Moles of solute, right, divided by kilograms of solvent. So what is percent? Well, percent is 20.00 grams of solute for every 100 grams of solution. So that's what that represents, right? So if you want to make this unit into molarity, what you have to do is you have to convert this into kilograms of solvent. We've already looked at how to do that a little bit in looking at percent calculations. And then this just needs to be converted into moles. So what we'll do is take this out in two steps. I'm going to calculate the moles of the solute, that is 20.00 grams times, right, 342.30 grams for every 1 mole of solute. So that's the first part of the problem. Now the second part of the problem is dealing with the 100 grams of solution. So how do you do that, right? Well, you know the proportions for the solution to the solvent ratio. And we know that because we're given the percent of sucrose. So that means there's 80 grams of solvent .00, excuse me. There's another 0 in here. 4 sig figs for every 100 grams of solution. So what we can do is we can get to grams of solvent by going 100 grams of solution for every 80 grams of solvent. So this will cancel out like this. And then the last step, which unfortunately I didn't quite leave myself enough room to do, is I got to get the grams of solvent to be in kilograms. So I know there's 1,000 grams for every 1 kilogram. That gives me 0.7304 moles per kilogram solvent, or 0.7304 molality units, like that. Okay. Again, I started with the definition of what percent was, and then I looked at my definition for molality and I converted the top over, and then I converted the bottom over into the unit that I needed. Okay. Now, let's go ahead and do the same thing for molarity. I'll just block off a little space here. I have, again, 20%, right? So 20.00 grams of solute. Now, I'm still going to have to convert that over to moles. So this part of the process doesn't change, but then it's how I deal with per 100 grams of solution. Oh, I was going to do that in a different color. Let me do the top part first. So this is still 342.30 grams for every 1 mole. But now I'm left with 100 grams of solution. And that's where the density is important, because that's going to allow me to go into units of volume. Because remember, molarity is moles per liter. So I'm going to have 1.084 grams. That's going to be on the top. For every 1 milliliter of solution. And then I need to convert milliliters over to liters, or you can do the very convenient. Just remove that and say 1 times 10 to the minus third liters. And then finish your calculation. And you get 0.6334. And this will be canceling out units, right? Moles per, and then I'm left with liters on the bottom, or 0.6334 molar. Again, same solution expressed with 2 different concentration units. You'll notice how different these 2 numbers are, and that's just because this is a high percentage of sucrose in the solution. So let's sort of summarize what we did, just hit sort of a general action plan. Is 1, you start by writing out the given concentration unit. Okay, so write out the given concentration unit. And then the second thing is you have to develop a strategy, but don't tackle the whole thing at one time. Convert, because they're always a ratio, right? Convert the numerator and denominator separately as separate problems. And then that'll help you sort of avoid some of the confusion that comes with converting concentration units, because you're often converting both the numerator and the denominator. So for percents or parts per billion, right, what you're going to literally write out is grams, percent, I have to write it like that. You're going to write out things like grams per and then 100 grams, right? But for molarity, what do you do? Because people often get stuck on that one. So let's say you had a 2.5 molar solution. Then you would write 2.5 moles per liter, or let's say you're going to have to do it as a density problem, then it's moles per 1,000 milliliters, for example. But this is for 1 liter. And then when you're doing your calculations, you have to convert the liters, for example, over to grams of solvent or grams of solution. And then the moles typically would get converted the same way all the time. Okay? But again, look at the units that you're given, write out those units as they are in their definition, and then start by converting the numerator to the numerator you need for the target unit, and then the denominator to the denominator you need in that target unit.